In this video, we're going to figure out how to calculate a moment. Now, we've done two experiments recently. The first experiment showed us that as we increased the force, the moment increased in size. And the second experiment showed us that as we increased the distance of the force from the pivot, then we also increased the size of the moment. So this brings us to our equation, which we have to learn. And that says that the size of a moment is equal to the force multiplied by its perpendicular distance from the pivot. Now in year 10 you just have to learn perpendicular distance from the pivot. When we get to year 11 that will become a bit more important. All the distances we will give you will be perpendicular at the minute. Now moments have different units, and basically the unit that you get out depends on the units that you put in. So let's do a couple of examples. So if we will always put our force in newtons, but sometimes we could measure our distances in centimetres. So if that's the case, then the unit of our moments will be newtons times centimetres, which is newton centimetres. Or if we decided to use a different distance, remember force will always be in newtons, but if our distance was measured in metres, then our moments would be newtons times metres, which would be newton metres. Or third option, there's lots of options though, we could actually have our force always in newtons, but we could have millimetres for our distance, so therefore the unit of our moment could be newton millimetres. So there are different possibilities for units for the moments, and it all depends on the unit that we use for the distance from the pivot. Now, the direction of a moment is also very important, and there's a separate video for you to watch on that to help you decide whether a moment is clockwise or anti-clockwise, because moments are turning forces, and when we turn in either a clockwise or an anti-clockwise direction. So I would like you to try that, watch that video, and you will find the answers to these four options inside that video. Now, I'm going to do a couple of worked examples here, and then you're going to do some yourselves and upload them for us to see your working out, okay? So the first example here, and I'm going to show you how you need to show your working out, and that's really, really important. So we always start by putting in our equation, and the equation for moments, so moments is equal to the force times its perpendicular distance. But it's okay inside an equation just to write m equals f times d. Now if I do that in an exam situation, I actually get a mark just for writing that down. Now let's go on to the next line where we substitute in our values. So our force is always measured in newtons, and in this example our force is 3 newtons. Our distance from the pivot, well here's the pivot here, here's our force, the distance in between them is that 40 centimetres, so my distance from the pivot is 40 centimetres. So that's my second mark. Then I actually calculate that, and I find that the moment is 120. So that could be my fourth mark, and then I have to say whether what the unit is. So my force was in newtons, my distance was in centimetres, so my unit is newton centimetres. And the fifth possible mark is for writing down the direction, because the question says remember to include the direction. So I would do my little trick with my pen, where I hold my pen steady at the pivot and push it in the direction of the force. And in this case, I would find that my moment was anti-clockwise. So therefore, that would be my fifth mark. Now to get the 5 marks, I need to show all that working out. So my first, so I'm just going to do one more example for you here. Well, I'm going to do both these two examples here. So example B, equation, moment equals force times distance. My force in this case is 4 newtons, and forces are always measured in newtons, so I know I'm right. My distance between the pivot and the force is this 200 millimetres, so I write in 200. Therefore, then for my next line, I write down the answer. 4 times 200 is 800. The unit is newtons times millimeters, newton millimeters. And my direction for this one, if I hold my pen at the pivot and push up, it will actually go in a clockwise direction. So that is 5 marks there. One equation, substitution, number, unit, and the direction. Okay, and my last example here, moment equals force times distance is my equation. The moment, the force is, again, always measured in newtons, so that's going to be 6. My distance between the pivot and force is that 15 centimetres, so I just put in 15. So I'm going to need my calculator for this one, sorry. 6 times 15 gives me 90. Okay, and my unit, force is in newtons, distance is in centimetres, so my unit is newton centimetres. And then I do my little trick where I hold my pen, and this time I push the rod down, and that is going to go in an anti-clockwise direction. So again, there's 5 marks for me. 1, 2, 3, 4, 5. I'm going to skip down here to these examples in question 1. I'm going to do the first one, and then I would like you to carry out question 2 and question B and C, and upload your answers into the assignment. So the first one. By the way, I haven't actually got all the units right here, so make sure that you include the correct units in your answers. So the first one, moment equals force times distance. The force is measured in newtons, so that's my 5. And my distance is 20 centimetres from the pivot to the force, 20 centimetres. So that is going to give me 100, and my unit is newtons times centimetres, and my direction, if I do my little trick, is going to be anti-clockwise. So, like I say, that's worth 1, 2, 3, 4, 5. Your assignment is to do these 2 questions, making sure that you include the correct units and the directions, and that will be worth 10 marks. Okay, so it's the same mark scheme: equation, substitution, answer, unit, and direction for the 2 questions. So that gives you the 10 marks, and upload that onto the assignment. Thank you.